Welcome to EdKonnect Academy, your online tutoring platform for math and English. Quality learning at affordable price. Visit us at www.edkonnect.com to block your free trial. The topic for the video is revisiting irrational numbers. So first word problem is show that 5 minus root 3 is irrational. So in order to prove it as irrational, first we need to prove that root 3 is irrational. So first step will be to prove root 3 is irrational by contradiction method. And then step 2 will be prove 5 minus root 3 is irrational similarly by contradiction method. So for the step 1, let us assume that root 3 is rational. Then if it is rational, I can write it as in the form a by b, where b is not equal to 0 and a and b are coprime. Squaring both sides, we get root 3 square is equal to a by b square. This implies 3 is equal to a square upon b square. From here, a square is equal to 3b square. Now a square is written as a product of 3 and b square. So this implies 3 divides a square. Then by the theorem that if p divides a square, so any prime number p divides a square, then p divides a. So this is the theorem. So if 3 divides a square, then 3 will divide a. So this will be our first equation. Now if 3 divides a, then a can be written as some multiple of 3, where m is an integer. So from here again, squaring both sides, we get a square is equal to 3m whole square, which is equal to 9m square. Now a square was equal to 3q square, and from here a square is equal to 9m square. Now a square was equal to 3b square and a square is equal to 9m square. So on comparing values of a square, we get 3b square is equal to 9m square. From here b square is equal to 3m square. Now b square is written as a product of 3 and m square. So we can say that 3 divides b square. Now by theorem 1 that we have already stated, we can write that 3 divides b. So this is our second equation. Now from 1 and 2, we get that a and b are not coprimes. This implies our assumption was wrong. And hence root 3 is irrational. So this is our step 1. Now let's go to step 2. We have to prove 5 minus root 3 is irrational. So now again by contradiction method, assume that 5 minus root 3 is a rational. So if it is a rational number, then we can write it in the form p by q. So 5 minus root 3 can be written in the form p by q, where q is not equal to 0. P and q are coprime and integers. So 5 minus root 3 is equal to p by q. Now if we simplify this, we get that 5 minus p by q is equal to root 3. Taking LCM on this side, q, 5q minus p is equal to root 3. Now if we observe that in LHS we have positive integers above, so this is an integer, and below we have q which is an integer, and q is not equal to 0. That means integer by integer, this number is a rational number. While we have proved in the step 1 that root 3 is irrational by step 1. So we can say that a rational number cannot be equal to an irrational number. But here it is saying that a rational number is equal to irrational number, which shows that our assumption was wrong. And hence 5 minus root 3 is an irrational number. So from here we have also understood that the sum or difference or product or quotient of a rational and irrational number is always irrational. So what does this statement means? That sum of a rational and irrational, for example 2 plus root 3, this number, or difference of a rational or irrational, for example 5 minus root 2, or product of rational and irrational, that means 7 multiplied by root 3, or quotient of irrational numbers, that means 7 upon root 3. These all numbers are also irrational numbers. Now let us solve another word problem. It says show that 7 root 5 is irrational. So again we will solve this in 2 steps. So step 1 will be to prove root 5 is irrational by contradiction. And step 2 will be to prove 7 root 5 is irrational by conclusion in previous slide. So let us go for the step 1. So assume that root 5 is rational. So if root 5 is rational, we can write root 5 in the form a by b, where b is not equal to 0 and a and b are co-primes. So from here, squaring both sides, we get root 5 whole square is equal to a square upon b square. So this implies a square is equal to 5b square. So again a square is written as a product of 5 and b square. So we can say that 5 divides a square. Now from the theorem that if a prime number divides a square, then it divides a also. So if 5 divides a square, this implies 5 divides a. So let this be first equation. So if 5 divides a, then we can write a as some multiple of 5. where m is any integer. So a is equal to 5m. Squaring both sides, we get a square is equal to 5m whole square, which is 25m square. So from here a square is equal to 25m square. Now on comparing values of a square, we have 5b square is equal to 25m square. From here we get b square is equal to 5m square. So this means that 5 divides b square, and by the theorem we can say that 5 divides b also. So a and b are not co-prime from 1 and 2. A and b are not co-prime. So this implies root 5 is irrational. Why? Because our assumption was wrong. Now for the step 2, since we know that the product of a rational and irrational number is also irrational, we have just realized this, we have stated this in the previous slides. So the product of a rational and irrational number is also irrational. So 7 root 5 is product of 7 and root 5. So 7 is a rational number and root 5 is irrational from step 1. So this implies that 7 root 5 is also an irrational number. We can also prove this thing by the previous method, that is by the contradiction method. So let us see that. So step 2, by contradiction method. So let us suppose 7 root 5 is rational. Now if it is rational, I can write 7 root 5 in the form a by b. From here root 5 can be equal to a upon 7b. Now see, the LHS, in the LHS we have irrational number. So this is an irrational number by step 1. And this we have a real number and 7b is also a real number. So real number upon real number is a rational number. It is written in the form p by q, and q is not equal to 0. 7b is not equal to 0. So this is a rational number, and irrational number and rational number cannot be equal. So this gives us a contradiction. Why? Because a upon 7b can never be equal to root 5, and hence 7 root 5 is irrational. Thanks for watching. Do visit edkonnect.com to block your trial lessons.